Our project in machine learning is Crime Predictor Introduction. What is this model? This is a predictive model that made to predict the violent crime rate based in a US community based on several input features such as income, poverty rate, educational level, population demographics, and police presence. Currently, it's using random forest regression model and gradient boosting regressor. What is this data set? We use the UCI Community and Crime dataset, which contain data from 1994 US communities and include 127 features like demographic, age, race, population densities, socio-economic data, income, education, unemployment, and lastly, law enforcement data, policing statistics. So what do we want? Target variable, violent crime per pop, a value between 0 and 1, indicating the rate of violent crime per population. Our goal, build predictive model to forecast violent crime rates based on community characteristics.
Graph and pattern. So for our general pattern, we get our pattern from the higher poverty and lower education level, police presence, and the composition of the population in that area. This is the graph that shows the number of the violent crime per population, and this is the graph that shows the median income. And this is the graph that shows that the violent crime rate is reduced by the police operation cost. And this graph shows the violent crime rate that's reducing with the median income. And this graph shows that the violent crime rate has a big cluster in the community that have the black population as the minority. But even in the 100% black community, the crime rate is still pretty high. And this graph shows that the violent crime rate has a big cluster when the white population is the majority, but it also has the higher crime rate when the white is blending in with the other races.
Okay, now let's see our problem and our solution. In the river problem, the violent crime is a significant issue that affecting community worldwide, leading to loss of life, economic costs, and psychological impact. It costs both the government and the normal person like us. In the United States, violent crime rates are influenced by various factors such as socio-economic condition, poverty, money, unemployment, income, or rents, and more. Demographics, age, race, educational level. Normally, we know that the lower the education, the higher the crime that will affect us. Urbanization, normally more people, more problems in the more densely populated area, it normally have higher crime rates. And fourth, policing and law enforcement presence. The higher police presence can reduce significantly the crime. And what is our application solution? First, it is a proactive identification of high-risk area. By using our application, we can analyzing the pattern and trend of the community data. Our model can help identify the area at risk and the harm. We can provide early warning to local authorities to heads up, allowing them to take a preventive action before the crime could take place. Secondly, resource allocation. Police department and local government can use this prediction to allocate resources more effectively, such as increasing patrol or provide social program in community predict to have a higher crime rate. For instance, area that predicted to have the higher poverty and lower education, we can provide more police or maybe community engagement program or economic development to reduce the crime rates in that area. And third, policy design. This will be useful for both the governor or the police. The model insights can support evidence-based policy making such as increasing investment in education and job training program can reduce the crime. So we increase the education, of course. Or second, improving access to the mental health service to address underlying issue linked to violent crime because sometimes the craziest person can do the craziest things. And third, enhancing community policing strategy in the area where crime is predicted to be high. As you can see from the graph, when you increase the police budget, the crime rate will reduce significantly. So of course, but you doesn't want to increase your cost in every area. So we just need to choose the only specific area only.
Now that we know why crime rate prediction matters and what data we are working with, let's talk about how we actually forecast those crime spikes. First, we will use the first model of the random forest regressor. Think of a random forest as a crown source dozen of tiny decision trees. Each tree see a different sample of our data, make its own prediction, and then we average those our prediction. That averaging silver a lot of overfitting and smoothing our noise. With just 100 trees and fixed rate random state, we hit an R of 0.615, meaning the model has expand of 61% of month-to-month crime variance. The real bonus is expandability. We can pull up built-in feature importance chart and show commanders exactly how factor drive risk in their district. Next will be gradient boosting regressor. Gradient boosting take the opposite approach. Instead of crowd voting all at once, it build a tree one after the other, each tree learning from the error of the last. This often squeeze out a touch more accuracy, but in our pilot data, it lands slightly lower at 0.593. While boosting is more sensitive to learning rate and depth tweak, and training is slower. Important if we want a nightly model refresh, it will be impossible. So both of these will have some different, but major difference is one is assemble method on breaking that build many decision tree, but the gradient boosting is more assemble based on tree builds sequentially. So each error will be collecting by the previous one. It is more accurate but require more careful tuning and is slower to train. The solution? Both models learn complex, non-linear relationship between two factors, can help predict harm slightly before they spike, so we can intervention early, and we can serve as a data-driven tool for the community safety assessment and policy decision.
Here I will start showing you what we think improve our model. So by integrating with external data from police department of health, it will not only help training the data but also improve the accuracy. As you can see here, American government and some other countries offer their previous years of data of community survey. So by requesting API, which could be useful for further data training. So the next one is model ensembling. What does it mean? It means combining multiple models to get better predictions, like getting multiple opinions instead of just one. There are two main types. The first one is the backing, like the random forest. It trains models on different data sources and combines their results. This reduces the variance and makes the model more stable. The next one is the boosting. These models learn from one after another. Each fixing the last one mistakes is great for reducing bias and handling complex data. Here is the cross validation. What is it? It's a technique that we use to make sure our model performs well, not just in one piece of data, but also across different slices of it. It helps us catch overfitting early and give a more reliable picture of how the model performs on new data. A common method is K-fold, where we split the data into K parts, train on some, and test on the rest rotating through. Another is stratified, which makes sure each fold has similar class distribution, especially useful for imbalance. So here is our member Firebus. So this is the end of our presentation. Thank you for your attention and see you again next time.